I'm going to go through the unit assessments on this chapter, starting with question 1. But before we even do anything like that, I'd like to let you know if you feel you know how to answer this question, if you want to try it on your own before you watch the rest of the question, you're more than welcome to do that. In fact, I'd advise you to try and do that. Let's start. Okay, question 1. What is the sum of the interior angles? Well, there's two methods you can do. You can either count the triangles and then times it by 180, or you could just say, hey, the exterior angles sum up to 360. So let's just do that. So exterior sum is 360 degrees, and a regular decagon has 10 sides. So 10 sides, 10 equal sides because it's regular. You can just do 360 degrees, divide by 10 to give us 36 degrees, which is one exterior angle. So to work out the interior angle, all we have to do is do 180 take away 180 take away 36. Interior is 180 take away 36, which is 144 degrees. So this interior angle here, this is just 144 degrees. Or you could have used the n minus 2 times 180, where n is the number of sides, so 10 minus 2 times 180, which is 8 times 180, which I believe is 1440 degrees, and then divide that by 10 to give you one interior angle, which is 144 degrees. There's so many ways you can do this. I prefer working out the exterior angle, which is really easy. It's always 360. Divide by 10, give you 36. And then for the interior, 180 degrees because it's a straight line. 180, take away 36, give you 144. Now moving on to 1b. In fact, we've already done 1b. 1b is asking us to work out the size of angle IJK. So IJK is over here, IJK, and you must have spotted that this is the exterior angle. So IJK, I'm going to use red again, is just 360 degrees, divide by 10 to give you 36 degrees. Moving on to question 2. XYZ is a right angled triangle. Calculate the length of XZ. Now XZ is this length here. Notice it's a right angled triangle. Two lengths are given. Work out its missing length. This is Pythagoras' theorem. Label it A, B, C. Make sure C is the hypotenuse opposite the right angle. So A squared plus B squared equals C squared. We don't know what A squared is. 13.2 squared is equal to 15.4 squared. So A squared is equal to 15.4 squared. Subtract 13.2 squared. And don't know what the answer to this is. We can work it up, surely. But that's just going to give us A squared is equal to 62.92. So to get what A is, we just have to square root on both sides. To cancel out that square root on both sides. So the square root of 62.92 is 7.93 to 2 decimal places. Don't forget your units, centimeters, so A is 7.93. Just do a quick check. Is it the shortest side? Yes, it is. make sure it's not bigger than the hypotenuse. If it's bigger than the hypotenuse, you've made a silly mistake somewhere in your calculation. Okay, moving on to question 3. PQR and XYZ are straight lines. So let's highlight PQR, XYZ. So P to Q to R and X to Y to Z are straight lines. PR is parallel to XZ, so PR is parallel to XZ. Good, they've got the little arrows to tell us as well. PY is equal to QY. PY is equal to QY. So if these lengths are the same, we know it's an isosceles triangle, and fantastic, they even gave us the lines in the question. Work out the value of A. Give reasons for your answer. You won't get marks if you don't give reasons for your answer. So let's start. How would we start this? Well, the first thing you would do, you try to work out the angle, or the easiest angle you can do, which is that. Since PQR is a straight line, we can just do 180 degrees, take away 118 degrees. Straight line. Angles in a straight line, so 280 degrees, and that will give you 62 degrees. And the reason for this is because angles on a straight line sum to 180 degrees. And this, all of this would give you 1 mark. This won't give you any mark. Moving on. Now, since this is 62 degrees, and we know that this is an isosceles triangle, the base angles must be the same. So this is also 62 degrees. Write it down. Okay? So, angle YPQ, so this is the angle YPQ. Take a look. So to make this angle here, the 62 that we wrote down, angle YPQ, or you could have written QPR, doesn't matter, QPR still makes this angle. YPQ is equal to 62 degrees because base angles on an isosceles triangle, triangles are equal. And this would give you the second mark. Moving on to working out A. Just a quick note, if you've written this is 62, in your diagram, write this is equal to 62, because base angles on a isosceles triangle are equal, you would also get a mark if you write your reason around here. Moving on, okay. We're trying to work out what A is, and angle A is here, and we also know what this angle is, and you can see this is a alternate angle. So A is equal to 62 degrees because alternate angles are equal. And this would give you the third mark out of 3. If you do not write your reasons, you won't get a mark. It's just that. The reason for that is because it's really easy to just know that this angle looks the same as that angle and say, hey, that could be 62, because these parallel lines are fairly accurately drawn from the question. Moving on to question 4. PQRS and XYZ are straight lines. PS is parallel to XZ. Prove that the angle sum of any triangle is 180 degrees. Now, please listen very carefully. Few students, and not many students that is, use the letters X, Y, Z and said these are the angles. They are not the angles. these are the points on the line. Here's a point P, point Q, point R, point S, point X, point Y, point Z. And when you join these up, you either get a straight line. P, Q, R, S is a straight line. X, Y, Z is also a straight line. PS is all of this line, and XZ is all of this line. These two lines are parallel to each other. Prove that the angle sum of any triangle is 180 degrees. Well, we need to start using the angles. The first thing you would start doing is saying this: D plus A plus E is equal to 180 degrees. And the reason for that is because X to Z is a straight line, or X, Y, Z is a straight line. Because angles on a straight line sum to 180 degrees. Straight line sum to 180 degrees. And then we're going to see that D and B, D is equal to B because alternates are equal. Alternate angles are equal. And in fact, we can just write here. I'm going to start writing like this. E is equal to C, as you can see from here. E is equal to C because alternate angles are equal. And that's nice, because alternate angles are equal. It looks a bit messy, sorry about that. I just realised I can typing would be much easier because you can see it. In fact, I'll pause this video and rewrite it neatly for you. Okay, now that we're back. Now, since D is equal to B and E is equal to C, we can substitute these letters into our equation over here. Now, what we're trying to prove is that A plus B plus C is equal to 180 degrees. Because this is here is a triangle, A, B, C. These angles are part of, well, from a triangle. So, if we've got D, which is equal to B, we can substitute it into there. And because we've got E, we can substitute it into there. E is equal to C, we can substitute it into there, and it'll give us 180 degrees. And that's the proof. I'll just write, so A plus B plus C is equal to 180 degrees. E will go into here instead to give us this C. D will go into, sorry, D will be substituted as B. So we got B plus A plus C, which is the same as A plus B plus C. Right, moving on to question 5. Question 5, you have to memorize these values and just write down the values. 5 marks, 5 questions. Cos of 90 is 0, sine of 90 is 0, sine 45 is root 2 over 2, tan 0 is 0, and cos of 30 is root 3 over 2. Right, a student started to actually draw out the triangle and work out what sine 45 was. So it's fine to do that. In fact, I prefer it because then if you know the method of working it out, you'll never ever need to memorize it, and yeah, you can work out any of the angles. Right, the students worked out the angle of sine 45, and they worked it out to give you 1 over root 2. And they said, sir, this is not, would this be alright? Would I need to rationalise the denominator? It's best to do it, mainly because we don't like root 2 at as the denominator. So to rationalize the denominator for this, we just have to times it by root 2 over root 2, times it by the denominator over the denominator. This is just equal to 1. So we haven't changed the fraction. I will also put rationalizing the denominator on MathsWatch for you to further practice if you've forgotten how to do it. But I'm going to go through it anyway right now. Okay, so 1 times root 2 is just root 2. Now, root 2 times root 2, same as saying root 2 squared. Now, root 2 squared, the square root and the square cancel out because they're the inverse of each other, and that will just leave us with 2. So root 2 times root 2 is 2. Same goes with, as an example of root 3 squared, is just cancel out to give us 3. I'm not going to go through this. Cos 30 is root 3 over 2, but this is a nice way of writing it instead of the way you would do it with a triangle. Moving on to question 3. PQR is a right-angled triangle. All fantastic. Okay, first things that should pop into your head, Pythagoras' theorem or SOHCAHTOA ratios. Now it says calculate the size of angle marked X. There it is. Give your answer correct to 1 decimal place. Right. Hypotenuse. I'm not going to speak too much on this. Hypotenuse. With respect to this angle, this is the opposite and this is the adjacent. Two things that we've got the hypotenuse and the adjacent. So from our SOHCAHTOA, if I can write it properly, SOHCAHTOA. The only things that we have is hypotenuse and adjacent, so we're going to use cosine. So cosine of x is equal to adjacent over hypotenuse, and the cosine of x is equal to, where's our adjacent? 5.8 over 7.3. To get what x is, we have to do the inverse, so cos inverse on both sides, cos inverse. I don't know why I've written the brackets there, just remember. Okay, and this will go with that, so we can cancel it out. So we got x is equal to cos inverse of 5.8 over 7.3, and it will give us a nice angle. Well done for those who've written everything out when they did this in the calculator. But I'm not going to do that, so I'm just going to give you the answer straight away. So x is 37.4 degrees to 1 decimal place. And that's what they wanted it. 37.4 degrees. Okay, moving on to question 7. To build a ramp, let me just explain to you what a ramp looks like on this question. So imagine here is a little curve from the road. So here's the curb and here is the ground. Looks really bad, but here's the curb, here's the ground. Now a ramp, all you need to do to make a ramp, you just need to put a piece of wood from the ground to the curb, and you can now ride your bicycle or whatever you want, or a motorcycle. But you don't need to cut the wood up. You just have to place it on the ground and on a high area, really, and you can just use one piece of wood. So when they said Dave builds a ramp with 1 meter of wood, he wants the vertical height of the ramp to be 50 centimeters. Well, he doesn't have to cut the 1 meter wood and place it on the curve. There's no need to do that because the walk curve is already there. Right, it's a bit of a strange question, but keeping that in mind, we're going to move on with the question. Let's just go through it very quickly. Okay, Dave builds a wheelchair ramp with 1 meter of wood. He wants the vertical height of the ramp to be 50 centimeters. What does the angle of elevation should be? Okay, so the angle of elevation is from the ground up So this is going to be our angle of elevation. Elevation there. It's always from the ground and it goes upwards like this. So from the ground to the ramp is the angle of elevation. And I'm just going to make the ground. So this is going to be the ground, and he wants a vertical height of 50 centimeters. So here's the 50 centimeters, and he has 1 meter of wood, and 1 meter of wood I am going to do in brown. So 1 meter of wood is there. So from the ground to the 50 centimeters, and I'm just going to make it look like a plank of wood. So there it is. And we're trying to work out the angle of elevation from the ground to the ramp. We're going to call this theta degrees, and this wood is 1 meter. Fantastic. Everyone who was doing this straight away converted it to 100 centimeters. Well done on that. But the 1 meter was either at a floor, which was not right, or it was parts. Well, or it was 50 centimeters because I thought the wood needs to be the vertical height. It doesn't have to be the vertical height because remember this is going to be the curve or the wall they're going to use to put the ramp on. And I don't really think I need to go through this because now that you've got the diagram, you've done the sketch, we can easily work it out. With respect to theta, this is the opposite, this is the hypotenuse. Just going to use a different colour to actually work it out. So this is the opposite, this is the hypotenuse. We need to use sine. So sine theta is equal to opposite over hypotenuse. Fill it in. Sine theta is equal to 50 over 100, and well, this is equal to a half. And sine theta is equal to a half. So theta, we just have to do the inverse of half, or we can use what we did here, I guess. Do we have sine 30? No, we don't. It should be 30 degrees. So inverse of a half is 30 degrees. So this angle is 30 degrees. Bit of a messy question, but it's really nice. Okay, Josie spots her brother Dan from the roof of a block of flats. The angle of depreciation from Josie to Dan is 85 degrees. The distance from Josie directly to Dan is 80 meters. Calculate the height of the block of flats. Give your answer correct to 2 decimal places. Again, there were some lovely sketches for this question. I really liked seeing someone drawing a proper flat, so I copied them as well. I'm not going to tell you who it was, but their drawing wasn't as nice as mine, just saying. Okay, so here's Josie. Josie is at the top of the flats. Right, so Josie's here. There's Josie. And she spots her brother Dan from the roof of the blocks. So she's on the roof of the blocks. So Dan is somewhere around here. Dan's hanging around here. The angle of depreciation from Josie to Dan is 45 degrees. So here's Josie. We're going to assume that this is where she's standing, and this is where Dan is, where he's standing. A really bad choice of colour. Let's use a different colour. It's green. And the angle of depreciation is 45 degrees. Now this is going to be a right angle triangle because the height of the flats is going to be perpendicular to the ground, and Dan is there. Now, angle of depreciation. If you imagine a straight line from Josie all the way across, this line is going to be parallel to that line. The angle of depreciation is from the top to the hypotenuse of the triangle. From the top to the hypotenuse of the triangle. This is 45 degrees. This here is parallel. If that's 90 degrees, that is also going to be 90 degrees because co-interior angles must sum up to 180 degrees. If that is 45 degrees, the rest must be 45 degrees. This was quite lucky because that was 45, this was 45. And going to the question again, the distance from Josie directly to Dan is 80 meters. So this directly to Dan is 80 meters. Okay. This sketch, I'm going to make it a little bit simpler for us to see. I'm going to have to draw the triangle again, much neatly. So here's our 90-degree angle. Here's Josie. I'm going to use J for Josie and D for Dan. This is 80 degrees, and this angle we worked out to be 45 degrees. Calculating the height of the flats. Well, we have an angle, we have the hypotenuse, we need to work out the adjacent. So we're going to use a cosine rule. So cosine theta is equal to adjacent over hypotenuse. Fill in the information that we've got. Cosine of 45 is equal to adjacent over 80. So multiply by 80 on both sides. Multiply by 80 will cancel out. So 80 times by 80 times by 80. We get 80 cos 45 is equal to adjacent. If you put this into your calculator, the adjacent is equal to 56.57 meters. So the height of the flat is 57.57 meters. Correct to 2 decimal places. I will put the question up on elevation and depreciation on MathsWatch, and sorry, not MathsWatch, Show My Homework for you to have a go. Okay, question 9. A rectangular gate has a diagonal bar running across it. The gate is 80 centimeters high and 2 meters wide. Work out the length of the bar. So here's the gate. And the diagonal bar running across it is going to be this bar here. It is 80 meters high. Sorry, 80 centimeters. Ooh, 80 meters. 80 centimeters high and 2 meters wide. Firstly, the units are not the same, so we need to make this into centimeters. So it's going to be 200 centimeters. And we have to work out the length of the bar that goes diagonally across it. This is going to be a right angle there, so we can use Pythagoras' theorem. Really easily, just do the 2 short sides squared and then square your answer at the end. We can start labeling it A, B, C, and we know that A squared plus B squared is equal to C squared. So A squared is going to be 200 squared plus 80 squared is equal to C squared, and that is equal to 46400 is equal to C squared, and square rooting it on both sides. So it's going to be square root of 46400, which equals to C, And if you put that into your calculator, the square root of 46400, 46,400 is going to be 40 root 29 centimeters in surds form. Here's our surd, the root 29. Now, one student made them all into meters. Meters. So I'm just going to quickly do that, show you that it still works. So 80 centimeters is 0.8 meters, and 2 meters is still just 2 meters. So they've done 2 squared plus 0.8 squared, and that's going to give us, is equal to c squared. That's going to give us 4 plus 0.64, which equals c squared, and so c squared is equal to 4.64. So square root on both sides, c is equal to square root of 4.64. And square root of 4.64, if I could know what that is, square root of 4.64 is going to give us, on a calculator, it's really nice, it's not showing up, is it? 0.8 squared? Yeah, they got a really nice value when they put this into the calculator. It's fine, but make sure that the units are going to be all in meters. But this would be the nicer way to do it. Make sure they're all in centimeters. And okay. I hope this video was useful. Remember, don't watch all of it. I hope you haven't watched all of it. Well, this near the end. I hope you haven't watched all of it. Just watch the ones that you need help on. If you have any questions, make sure you come to me and we'll go through some questions. Okay, bye.